Good morning, friends. Today we discussed shear force and bending moment diagram question. So, a cantilever beam length 2 meter carries point load as shown in figure. Draw the shear force and bending moment diagram. So, how to draw the shear force and bending moment diagram? So, initially we have to draw the diagram like it is a cantilever beam. It will be one end fixed, another end will be free. So that is known as cantilever beam. From that given figure, we noted the point A, B, C and D. So D having point load 800 Newton, C having point load 500 Newton, B having point load 300 Newton. So distance will be A to B 0.5 is a meter. A to B 0.5 meter, B to C 0.7 meter and C to D 0.8 meter. So we have to next calculate the shear force and bending moment diagram. By calculation shear force, how to calculate the shear force? So in shear force we having a concept of only we consider point load plus right side load. That is the concept of the shear force. We calculate the shear force at point D. Shear force at point D, the value will be 800 Newton. Why means point load plus right side load. So here will be D point will be point load will be acting. So one load will be acting. So that's why we can put 800 Newton. So next shear force at C. Shear force at C, the point load will be acting 500 plus 800 Newton. So two load will be acting. So total will be the 1300 Newton. So this load also we add, this load we also we add. So next point will be the shear force at B. We consider shear force at B. We can add the all load values like 800 plus 500 plus 300. So total the value will be 1600 Newton. So at last shear force at A, already we find the values 1600. So total the load DCB is 1600 Newton. Finally shear force value we get the positive way of order. Next, how to calculate the bending moment? So in bending moment calculation we consider point load plus distance from the right side. So that is the main point. So we found bending moment at D. So with bending moment at D, here sign conversion is very important. Right side sign conversion very important. If it is the bending moment is clockwise, minus sign. If the bending moment is anti-clockwise, positive sign. That is the main important of this bending moment concept. So we have to find the value bending moment at D equal to minus 800. How minus 800 means one end will be fixed. The bending moment of point load D is down. So the bending moment will be like this clockwise direction. So that's why we can put minus 800. So distance will be 0. We multiply, the value will be 0 kilonewton meter. Second, bending moment at C. The bending moment at C, we consider bending moment at D point minus 800. Total distance will be the 0.8. So that is the value of minus 640 kilonewton meter. The unit conversion is very important. At third load, bending moment at B is we calculate minus bending moment at C at the point bending moment at C will be the having load 500, but the distance will be 0. That's why we cannot consider the bending moment point C load. We consider right distance from the right side, right. Cut one. So here the shear force values are calculated clearly. The answer values are came in positive sign. So we have to draw. This is the D point. This is the A point. From D point, shear force at D will be the 800. That is the positive sign. So shear force values are calculated like this positive sign. So we have to draw the shear force diagram. So first the point will be D. So shear force at D will be the 800 Newton positive sign. We can positive sign will be the shear force diagram reference line. Above is the positive, below is the negative sign. Bending moment also same concept. Above is the positive, below is the negative sign indicate. So from the shear force diagram 800 Newton from shear force at point D 800 Newton, we can put 800 Newton at the point. Okay, next point shear force at C. What is the value of shear force at C means 1300 Newton. So 1300 Newton means from 800 this point 1300 we put approximately this point, that is the point of C. We notate D, this point also E. Okay, shear force will be the straight line. We can constant line from here the point of D and when joining the point of shear force E point. So next we find out the value shear force at B is 1600 Newton. 1600 Newton. What is the point of C point value is 1300 Newton. So what is the shear force at B means 1600 Newton. We put approximately this value 1600 Newton. That is the value of F. This is the constant line from here. And when joining this point is okay. So at last the shear force at A point 1600, same value will be obtained. We get close the point. So this is the result of the shear force diagram. This is the shear force diagram. By using this calculation, we have to draw the shear force diagram. Will be the bending moment calculation. Here the concept is point load plus distance. We have to add. So first the bending moment at point D. Here the load will be 800 clockwise direction minus 800 into the distance will be 0. So that's why empty point will be 0. Bending moment at point will be 0. We have the notation of point D and here A. So next bending moment at C. So here the bending moment at C point load will be 500. The distance will be known, so that's why we cannot consider. From right side we consider 800 load. Distance will be the 0.8 minus 800 into 0.8. We multiply that value of minus 640 kilo Newton meter. So here we can draw the straight line. So next we consider the point B, bending moment at point B. So minus 800 into the total distance 0.8, 0.7 we can add into 1.5. So another node will having 500 minus into 0.7. So total the value will be the minus 1550 kilonewton meter. So approximately we can put minus 1550 kilonewton meter. So at last point, bending moment at A. So we already find the bending moment at B value. So we can put bending moment B value minus 1500 from B itself. So another, the point of bending moment at B. So we consider bending moment at A. So minus 1500 minus of 300 Newton into 0.5 is the distance. So we can multiply, final answer will be minus 2350 Newton meter. So approximately the value will be minus 2350 Newton meter. So here we can draw the line. So here we completing the profile of bending moment diagram. The symbol will be minus. Here this is the bending moment diagram. This is the shear force diagram. So hence, finally, by using the calculation of shear force diagram, we draw the shear force diagram. By calculation by finding the values of bending moment diagram. By using these values, we have to draw the bending moment diagram. So finally, we calculate the shear force and bending moment diagram. So we have, by using this value, we draw the shear force and bending moment diagram. Thank you for all.